Let's start the exercises. Let's start with this second one. Here the equation is xy plus 2x plus y plus 2 times dx plus x square plus 2x times dy equal to 0. You will see that this is a separable equation, and the equation can be turned into this form, and we write the solution like this. The given equation can be expressed like this, where the variables x and y have been separated, and we get this x plus 1 dx divided by x square plus 2x plus dy divided by y plus 2 equal to 0. Note that this term xy plus 2x plus y plus 2 is x plus 1 times y plus 2. So now that the variables have been separated, we can integrate both sides. That's it. So you do the integration. Integrating, we get this. In anticipation of what you are going to have here as these two integrals, you are going to have natural logarithm, we write the right hand side like this. Instead of simply writing an arbitrary constant c, we write ln of mod c. We need this absolute value to maintain positivity. C cannot be negative. So C is an arbitrary constant. Oh, I forgot to write one thing. C also cannot be 0. So you add that, where C not equal to 0 is an arbitrary constant. Okay. And then what happens? What about these integrals? What is the differential of this denominator x square plus 2x? This is 2x plus 2 times dx. We have x plus 1 times dx here, that means we do not have 2, so we need 2, and that is why we multiply and divide by 2. So there is actually another step which I have not written. So 1 over 2 times integral of 2x plus 2 dx divided by x square plus 2x, and that you already know is ln of mod x square plus 2x. 1 over 2 is outside. This one is just directly ln of mod y plus 2. That is because the differential of y plus 2 is just dy. And on the right hand side, of course, you have this. And then you apply your rules for logarithm that you already know. This 1 over 2 comes inside and becomes the exponent, giving you this square root of mod x square plus 2x. And you also have sum. So that means ln of square root of this plus ln of this. So that means ln of their product. So you have product, and on this side you have ln of mod c. And then when you cancel ln from both sides, which you can because ln is an injective function. It's a one-to-one function. Or you can just take exponent on both sides. That is ln of this equals ln of this, then you take exponential function on both sides. E to the power ln of this equals e to the power ln of this. So that way this is what you get. You can still simplify this a little more by getting rid of these absolute values. How? Well, what is mod y plus 2? Either it is y plus 2 or minus of y plus 2. Similarly, this one is plus or minus c, because c after all is an arbitrary constant. So even if you have minus on this side, then that is also just some constant. And note one more thing, that we have assumed c to be non-zero, although I have not written that. However, you can take c to be 0, and c, whatever you are getting here, is really a solution to the original differential equation. You will see that it will be. It's just a thing that here we need the condition that c has to be non-zero. So let us write the final line after this, and that is this square root of mod x square plus 2x times y plus 2 equals c. This is a one parameter family of solutions of the original differential equation. Next we have number 4. where the equation to solve is cosecant y dx plus secant x dy equals 0. Now before we start the solution, let me remind you of something about this type of problems and their solutions. What did we do in the previous solution? That was also given in differential form like this one. Something times dx plus something times dy equals 0. We had to divide by some things in order to turn the equation into a form where the variables are separated. Now you already know that whenever you do division, you have to make sure that whatever you are dividing by, that is not equal to 0. We however did not really care that much about writing those things that we are dividing by, say, y plus 2 in the previous solution. So y plus 2 should not be equal to 0. Actually we have to carefully do division whenever we do. Here however the aim is something else. The aim is to familiarize ourselves with these methods. The aim is to recognize that whenever you have a differential equation, it belongs to a particular class. Say it's a separable equation or a homogeneous equation, and then we have to be able to apply the method for solving equations in that particular class. And whatever we ultimately get as solution, that may not actually be a solution. I mean, do you recall that I said here that although we are assuming C to be an arbitrary non-zero constant, because we needed that condition, the way we obtained this equation, there we needed that condition, but then I added that even if you take C equal to 0, you will get this times this equal to 0, so that will also be a solution to the differential equation. It may not be, or it may be, but that's not really our concern here. We are not trying to see whether whatever we are ultimately getting really is a solution or not. Here the main thing is learning to apply the method. That's what it is. Okay, so with that understanding, let us now solve this one. So the given equation can be expressed as this, and to do that, what should you do? You multiply both sides of this equation by sin y cos x. If you multiply cosecant y by sin y, you will get 1. But with that you also have cos x, so that way you get cos x dx. Multiplying secant x by cos x, you get 1. But with that you have sin y as well, so that way you get sin y dy. So that's how you have separated the variables. This part has only x and this part has only y. So now you can integrate because it has become a separable equation. And everything is so straightforward and easy here, because whatever you are going to get as these integrals, that does not, however, those things will not have natural logarithm or anything like that. They will simply again be trigonometric functions. So on this side we can just take our normal arbitrary constant c. So thus next we are going to write the equation, the integrals. So integrating cos x with respect to x, we get sin x. Integrating sin y with respect to y, we get minus cos y. So sin x minus cos y equals c, where c is an arbitrary constant. And again I am telling you that whether this, you can see that this is a somewhat complicated relation involving x and y. Whether this implicit solution really gives you an explicit solution of the differential equation is yet to be seen, but we do not care at this stage. Getting this is our aim. We will think about those things afterwards, that whatever we have got really is giving us solutions or not. Next we have number 6. The equation to solve here is this: e to the power v plus 1 times cos u du plus e to the power v times sin u plus 1 times dv equals 0. So you see that we no longer have x and y, instead we have u and v. It does not really matter what we call these variables, u, v, x, y, alpha, beta, anything we can name them. So in the solution we first separate the variables, we can, because this one is also a separable equation. And after going through the necessary steps, this is how you can express the equation. Cos u du divided by sin u plus 1 plus e to the power v dv divided by e to the power v plus 1 equals 0. So the variables have been separated, so we can integrate. And integrating, this is what we get. So again, because we already understand that natural logarithm is going to appear, so the right hand side is taken like this, like before, ln of mod c, where we will now write where c is the non-zero arbitrary constant. So we write that condition where c not equal to 0 is an arbitrary constant. And then you already know what these integrals will be. The differential of sin u plus 1 with respect to u, of course, is cos u du. The differential of e to the power v plus 1 with respect to v, I should not perhaps say with respect to v because it's just differential, is e to the power v dv. So that is why the first integral is ln of mod sin u plus 1 and the second integral is ln. Why did I not use modulus, absolute value here? That is because e to the power v is never negative. Actually it's never 0 also, and on top of that we have plus 1 also, so this is always positive. That is why I just simply wrote it like this. If you want, you can use modulus. And on the right side we have this. So using the usual logarithm rule, ultimately this is what you get. Now you can lift absolute value, because this c again is an arbitrary constant, so even if minus comes, that will be absorbed in c, and you get your one parameter family of solutions like this: sin u plus 1 times e to the power v plus 1 equals c. Again, solutions within quotes. Are these really solutions? That we have to see, which we won't see right now. Next, let us see number 14. You can try the other ones before it. Now here the equation is not really separable, but it is homogeneous, and you can see what the equation is: root x plus y plus root x minus y times dx plus root x plus y minus root x minus y times dy equals 0. So just from this you cannot so simply separate x and y. So we start the solution by declaring that the given equation is homogeneous, and that is because when you express the equation in derivative form, it's given in differential form. When you express it in derivative form, this is what it becomes. And then after necessary manipulation, you can turn it into a form like this, where you are only seeing the entire thing as a function of y divided by x. So by definition it's homogeneous, and now we have to apply that change of variable that will turn this into a separable equation, and that change of variable is y equals vx, where v is a new variable which is going to replace y. X will remain. So you next write the change of variables: y equals vx, where v is the new variable, and then you see what dy dx is. By the product rule for differentiation, that will be v times dx, which is 1, plus x times dv dx. So now you can replace dy dx with this, and on the right hand side, which is in this form, you can write v in place of y divided by x, and the right hand side looks like this, and this is a separable equation. You just have to separate the variables by going through the necessary calculations, and then you can integrate as usual and find a one parameter family of solutions which will have x and v, and then in place of v you have to write y divided by x back in order to turn it into an equation involving, or a relation whatever it comes out as, involving y and x. I am leaving those calculations to you. Let's see what you come up with. If you cannot come up with anything or you get stuck somewhere, you write in the comment section below.